So the last set of problems that we did with rate, time, and distance focused on the distance side of things. So you always multiplied the rate times time column, you got the distance column, then you either added the distances together or you did things using a total distance. These problems, though, that we're about to do are going to not so much deal with the distance, but deal with the time. So if I refer back to rate times time equals distance, well, how would we solve this so that time is isolated? Well, we know r times t equals d. So let's divide both sides by r, and now that isolates our time. So the time is equal to the distance divided by the rate. And that's going to be super important as we're going to go through and solve this first problem here. The speed of train A is 12 kilometers per hour slower than the speed of train B. So we immediately know that A is going to be x minus 12 if we make the speed of B be x. Now we know that train A travels 230 kilometers in the same time it takes train B to travel 290 kilometers. Find the speed of the train. Notice here there's nothing about total distances. The distances are not equal. We're not adding the distances up here either. Instead, we need to use the fact that it takes the same time for A to go 230 kilometers as it takes B to go 290. So that's where this formula, time is equal to distance divided by rate, is going to come in. Rather than multiplying, as in the last time, rate times time to get your distance column, you are now going to take the distance and divide it by the rate and put that in your time column. So in the case of train A, that's going to be 230 divided by x minus 12. And in the case of train B, that's going to be 290 over x. And now we know that it takes the same time in both of those cases, so then we could set those two things equal. So 230 over x minus 12 equals 290 over x. And now we have a proportion to deal with here. And you may remember from your previous work with proportions, we could cross multiply and set the products equal. So 290 times x minus 12 equals 230 times x. So 290 times x minus 12, 290 times x is 290x, and then 290 times 12 is going to give us 3480 equals 230x. Now bring all the x's to one side. So let's subtract 290x, subtract 290x, and we get negative 3480 equals negative 60x. Divide both sides by negative 60, and we get that x is equal to 58. So what that tells us then is that is the speed for x. So that's the speed for train B. We know that that is 58 kilometers per hour. Now, to get the speed of train A, we are going to take 58 minus 12, which is going to give us 46 kilometers per hour. So this problem requires a different setup than what we did previously. We can't, like I mentioned, add the distances. We can't set the distances equal because the time is the same here, not the distance, nor are we given a total distance, right? So you have to use the fact that the times are equal and manipulate rate times time equals distance to isolate for time. Now here's another problem that tackles a similar issue. Isabel ran the first leg of a 12-kilometer road race at a speed of 9 kilometers per hour, and the remainder of the race at 10 kilometers per hour. If her time for the whole race was 1 hour and 15 minutes, how long was the first leg of the race? So immediately, you may notice, I went and I filled out the rates. The first leg is 9, the second leg is 10. The distance-wise, well, we know that the total distance is 12. So, if in the case of the first leg, we call that distance x, the distance for the second leg is going to be 12 minus x. Now, we know that the total time for the race was 1 hour and 15 minutes. So now 1 hour and 15 minutes, we already have our rates in kilometers per hour. So that means that in order to solve this successfully, we need to convert 1 hour and 15 minutes into hours. So you can't just, deal with it in minutes. you need to convert it to hours because that's what our units are in for our speed. So an hour and 15 minutes is 1 1/4 hours, right? Because 15 minutes is a quarter hour. So that is going to give us, as a fraction, 5/4. So then we know that the sum of the times was an hour and 15 minutes. So let's figure out if the rate for the first leg is 9 and the distance is x, we know our formula, d equals r times t. Let's solve it for time because we're given a sum for time. Divide by r, d over r equals t. So our distance is x, divided by our rate is 9. Our distance is 12 minus x, divided by our rate, which is 10. And then we know that the sum is going to be equal to 5/4, our total time. So x over 9 plus 12 minus x over 10 equals 5/4. And now we have an equation to solve that involves fractions. So we have to think about what is our least common denominator between 4, 9, and 10. Now, as a refresher, you could find LCD a couple different ways. You could list out the prime factorizations. You could do something like repeated division, or birthday cake is how, when I taught in middle school, I used to refer to it. So I'm just going to show you the birthday cake method or the repeated division method in case it's been a while since you found an LCD. So the way it works is you make an upside down division box and you put your numbers inside. And what you're looking for is what is one number that goes into any two or all three of those numbers. Well, let's start with 2 because 2 goes evenly into both 4 and 10. So divide by 2. 4 divided by 2 is 2. 9 divided by 2, well, that doesn't happen, so we just carry down the 9. 10 divided by 2 is 5. So in other words, you only pull out what is in common to 2 or more numbers. If it's not in common to the number, you just carry it down. 2, 9, and 5, well, there's nothing in common besides 1, so now we make the letter L, so that means this here, and now we multiply. 2 times 2 times 9 times 5, that's going to give us 180. So that tells us that 180 is the least common denominator of all of these. So a useful technique that you could use after you found the LCD is just multiply both sides of the equation by that LCD, and that's going to cancel out the denominator. So let's multiply this side by 180, and let's multiply this side by 180. And now let's go ahead and simplify it. So 180 times x over 9 plus 180 times 12 minus x over 10 equals 5/4 times 180. 180 times x over 9, well, we know that 9 goes into 180 20 times, so that's going to leave us with 20x. We know that 10 goes into 180 18 times. That's going to be 18 times 12 minus x. And then 5/4 times 180. Well, we know that 4 goes into 180 45 times. And we know that 5 times 485 is going to give us 225. Now we have this equation to solve. So let's go ahead and let's distribute the 18. So 20x plus 18 times 12 is going to give us 216. 18 times negative x, that's going to be minus 18x equals 225. Combine our like terms with a 20x and negative 18x, that's 2x plus 216 equals 225. Subtract 216, 2x equals 9, so then x is equal to 9 over 2, which is 4.5. So let's go back to the question. How long was the first leg of the race? Well, the distance is x. That's what we solved for. So then we know that the distance of the first leg is 4.5 kilometers. Let's look at one more problem. Student lives 11 kilometers from school. On her morning commute, she walks to a bus stop at an average speed of 6 kilometers per hour. She then rides the bus for the remainder of the distance, an average speed of 45 kilometers per hour. If the entire trip takes 32 minutes, what are the times spent walking and riding the bus? So now we have our first part, which is our walk. Then we have our second part, which is the bus. The rate of the walk is going to be 6 kilometers per hour. The rate for the bus is 45 kilometers per hour. Now, the entire trip takes 32 minutes. Once again, be cautious of the units. Our rates are in kilometers per hour. The trip is in minutes, so we need to think of that in terms of an hour. So that's 32 over 60, which now you should simplify. So I could divide both by 2. That's going to give us 16 over 30, which I then could divide by 2 again, which gives me 8 over 15. So that is going to be our total time. Now, the distance. The student is 11 kilometers per school. So the distance, let's say, for the walk is going to be x. So then for the bus, that's going to be 11 minus x. The time, we're given the sum here. We know that it is 8/15. So the time is going to be the thing that we're solving for here. So once again, distance over rate equals time. So x over 6, 11 minus x over 45. Now let's solve. X over 6 plus 11 minus x over 45 equals our total time, 8 over 15. So now we need to figure out what's our common denominator for 6, 45, and 15. So let's make our repeated division box. 6, 45, 15. Well, 3 goes into all of those. 6 divided by 3 is 2. 45 divided by 3 is 15. 15 divided by 3 is 5. Now, 2, 15, and 5, well, 5 goes into both 15 and 5. So 2 we carry down. 15 divided by 5 is 3. 5 divided by 5 is 1. So now there's nothing in common between 1, 2, and 3 besides 1. So now we can make our LCD. So our LCD is going to be 3 times 5 times 2 times 3 times 1. So that's 15 times 6, which is 90. So same strategy as last time. Multiply both sides of the equation by 90, which is our LCD. So we get 90 times x over 6 plus 11 minus x over 45 times 90 equals 8/15 times 90. Now 90 divided by 6 is going to give us 15x plus 90 divided by 485. That's 2 times 11 minus x equals 15 and 90. So the 15 goes into 96 times. So then that's going to give us 6 times 8, which is 48. Let me make a little more room here. So now we have this equation to solve. So let's distribute out the 2. So we're going to end up getting 15x plus 2 times 11, that's 22. 2 times negative x, negative 2x equals 48. Combine our like terms, so 15x minus 2x, so that's 13x plus 22 equals 48. Then we're going to subtract 22. 13x equals 26. So then x is equal to 2. So that tells us that the distance for walking is 2 kilometers. And so then the distance for the bus is 9 kilometers, because it's 11 minus 2. So this is, once again, similar idea, except you need to keep in mind the units of the rate. If the rate is in hours, your time needs to be in hours. Now, I do just want to show you, you could use a system of equations for these as well, instead of having to deal with all the converting the d equals r times t and all that stuff. So if I was to fill out a table that way, so here's walk, here's bus, we still keep the rate to be 6 and 485. Now let's kind of think about the time. If I wanted to do this as a system of equations, I don't know much about the time besides what the total is, right? We know it's 32 minutes. So let's just say that we walk for x, and we're on the bus for y. Well, we can actually now say that the distance is 6 times x, and the bus is 45y. And we have enough information to now write a system of equations. We know that the total trip is 32 minutes, which we said is 8/15. So that tells us that x plus y is equal to 8/15. And we also know the total distance, because we know that the total distance is 11 kilometers. So then we could say 6x plus 45y equals 11. Now we have a system of equations to solve instead of having to deal with the fractions and all. So let's use elimination. If I multiply the top one by negative 485 to cancel out the y's, I now get negative 45x minus 45y equals, now let's do off to the side, negative 45 times 8/15. Well, 15 goes into 45 3 times, so then I get negative 24. Bottom equation stays the same. 6x plus 45y equals 11. Now let's add them up. So if we add them, the y's disappear. We have negative 45x plus 6x. That's going to give us negative 39x equals negative 24 plus 11 is going to give us negative 13. Divide by negative 39, divide by negative 39, and negative 13 over negative 39 is going to give us 1/3. So we know that x is 1/3. So then if we plug this into here to solve for our distance, 6 times 1/3 is 2, which is the same answer that we got up here. So I will leave it up to you as to if you want to approach these problems from the d equals r times t and do this with the system of equations with two variables, x and y. Or if you just want to stick to one variable, you can manipulate the d equals r times t formula in order to solve for what's being set equal, or what you know the sum of.